In the previous video, we saw two different force scales connected to the same string. Now you can see that in this video, we're stepping it up a bit. Over here, I have the brass ring, and the brass ring is connected by three different strings to three different force scales. Now, what's going to happen in this demo is that those two force scales on the left of the screen, I'm going to control directly. And this third force scale over on the right of your screen is going to respond to whatever I'm doing with these two force scales. So to start, let's say I take this force scale that's connected to the shorter string here, and I'm just going to pull it so that it reads 4 newtons. And that 4 Newton reading is telling you, it's telling you, among other things, that this short string here is exerting a 4 Newton tension force on the ring, pulling the ring to the left with a 4 Newton tension force. Okay, now let's say to that I'm going to add that I'm going to pull on this force scale over here that's connected to the longer string, and I'm going to try and pull on this force scale over here so that I get a 6 Newton tension in the longer string, which tells us, among other things, that this longer string is exerting a 6 Newton tension force on the ring, pulling it also towards the left. Now let's say I do that at the same time. Okay, so now I have a 4 Newton tension in the shorter string, a 6 Newton tension in the longer string, and I wonder what that third force scale all the way on the right there that I'm not touching is reading. Well, how about that? So if I get one of these to read 4 newtons and the other to read 6 newtons, it looks like that third force scale all the way over there on the right of your screen reads about 10 newtons. How about that? 4 plus 6 equals 10. Interesting. Okay, let's change this up a bit. Let's say I'm going to take the force scale here connected to the shorter string, and I'm going to pull it so that we have a 6 Newton reading telling us that the short string here is applying a 6 Newton tension force to the ring. And how about this other force scale attached to the longer string? Is 8 newtons. So we have, okay, so one string now is pulling the ring to the left with a 6 Newton tension force. One string is pulling that ring to the left with an 8 Newton tension force. And let's see here if I can get both of those just at exactly where they're supposed to be. And we look at that force scale over there on the right, and it's 13.5 newtons. Well, it's closer to 14 newtons than it is to 13 newtons. Closer to 14 newtons than it is to 13 newtons. 13.5, well, within the half Newton uncertainty of these force scales. I think we can call that 14 within uncertainty. All right, let's do one more. So now let's say I go to 8 newtons with the force scale attached to the shorter string. And let's say I go to 10 newtons with that force scale attached to the longer string. It's so easy to get these both at the same time to exactly what you want. Oh, that's pretty good, right? So now I have 8 newtons, right? So now I have my 2 strings that are pulling to the left. My 2 strings pulling to the left. Oh, it's so hard to keep these. My 2 strings pulling to the left. One is exerting an 8 Newton tension force to the left. The other is exerting a 10 Newton tension force to the left. Oh, I'm really trying to get these both where they're supposed to be at the same time. Okay, one's pulling to the left at 8 newtons, one's pulling to the left at 10 newtons. And how about that? The reading on that tension scale over there to the right is about 18 newtons. Okay, another fascinating coincidence. 8 plus 10, in fact, does equal 18. Okay, so the question now is, how can we relate an 8 Newton tension force to the left, a 10 Newton tension force to the left, and an 18 Newton tension force to the right? Now we know that 8 plus 10 is equal to 18, but that's not what I'm looking for, right? 8, 10 and 18 are the tensions in the strings. Those are not the tension forces. I want to know specifically, how is an 8-Newton tension vector pointing to the left, a 10-Newton tension vector pointing to the left, and an 18-Newton tension vector pointing to the right, how are all three of those tension force vectors, including both magnitude and direction, all connected to each other? Okay, and in the next video, I'm going to go back onto the board and we'll talk about what that all means.